So hi everyone. So let's continue with the course in calculus. So last time we were discussing functions, but we didn't make it that rigorous. So let's today study functions and study domain and codomain, as well as exponential functions, and call it a day from there. So let's start with functions. So let's say we have a function f from two sets, a to b. So again, like a and b are collections of objects. So sigma f, which is a subset of a cross b, is the function, and it satisfies the following condition. If a, for every a inside of a, there exists a unique b inside of b, such that a, b is an element of this function, which is a subset of a cross b. We say f of a is equal to b for that particular input, where b is that particular output for that particular input, a. So let's define a couple of things. So a here, let's define it as, let's write it like this. So the domain is all the allowable input that the function is defined on. That function is defined on. The codomain is all the allowable output that the function can take. So in this case, it's a. Or in this case, a. And the codomain, all the allowable output. And the range is all achieved output. So let's see an example. So let's say we have the collection of sets being 1, 2, and 3, and 4. And the outputs are A, B, C, and D. So if 1 goes to A, and 2 goes to A, and 3 goes to B, and 4 goes to C, then that means that here we don't achieve all of the codomain. So the range is precisely A, B, C, and C without D. All right. And compare to this function here. 1, 2, 3, and 4. And A, B, C, and D, where we send 1 to A, 2 to B, 3 to D, and 4 to C. Then this function achieves all the possible outputs that we have. We call such a function surjective. So first of all, we'll define it in a few moments, but first of all, notice that let's define the range. So the range is the following set, f of a, which is all those b's that are achieved as outputs from the input, where there exists an a inside of a, not necessarily unique a, such that f of a is equal to b. So notice this is a subset of b. So of course I'm just gonna assume that you guys know the notation for subsets, etc. But for the safety reason, I will touch on this in the in this video. So here is you have two collections of sets, A subset of B. This means for every element in A, it's an element of B. All right. So let's define another set here. So let me explain something after I define this set. F inverse of B is those particular A in A such that F of A is inside of B. And let's say that C is, let's call it D instead. D is a subset of B. Then we have F inverse of D is all of the subsets, all the elements in A that maps to D. So given a function f from A to B and sets and subsets A1 subset of A and as well as A2, which is a subset of B. B2, let's call it B1 instead. B1. So we can, given a function and given two subsets of A and subset of B, there exist the following subsets. F inverse of B1. This is all of the elements in B, all the elements in B, all the elements in A, all the elements in A, such that F of A is inside of B1. And F of A1 is all the achieved outputs where A1 is all, you're restricting the function on the set A1. So then what you have is that you're allowing all of the, like you're detecting all of the outputs that come from this set. So it's a B inside of B, such that F of B is inside, no, it's all those B's where such that there exist in A inside of A1, such that F of A is equal to B. All right. So what happened? What is happening here? So what's happening here is that if we have a function from A to B, this is particular. How this works is that you have a subset of the Cartesian product that have unique data, where this unique data is all the possible for each input, all the possible unique output for each input. So for each input, you can only have one unique output, and that's it. All right. So then we define the function to be as follows. So A and B is inside of sigma f. This means that F of A is equal to B. That's how we define it. So then given subset A1 subset of A and B1 subset of B, we have a unique, there exist possible, so there exist two subsets of A and B where the function generates them. The function generates them. So what do we mean by that? So we mean that like the function gives those particular subsets of A and B where it works for any subset of A and any subset of B, including B and A itself. All right. So now given this, let's define what is a surjective function. A function is surjective how is it defined? It's all it's all those. So a function is surjective if the codomain is achieved for every B inside of the codomain. There exists an A inside of the domain such that f of A is equal to B. It's not necessarily unique A. Function is injective if you have the following condition: if all of the outputs are unique. So they come from every input only has one unique output. So if f of A is equal to f of B, then we have, this means that A is equal to B. So now, if the function is surjective and injective, that means for every B inside of B, there exists a unique A inside of A such that f of A is equal to B. So a function. So this is also called onto, and this is called also one-to-one. Alright guys, like it's been a really fun video, and next time I'll talk a bit about bijective function, which is the story where we put surjective and injective together. And I'll put surjective and injective together, and we'll also develop exponential function and also half-life, and we'll deal with those things next video. Alright guys, it's been fun, and I'll see you in the next lecture.